Okay, we can start. Yeah. Hi everyone, I'm Manvesha. I work at Hasgeek. I am managing the AI and Risk Mitigation project. So today's session is the second session under this project, and this is a series that we're holding on Anthill Inside. So Anthill Inside is a community where topics in AI and deep learning, such as tools and strategies for implementing AI in businesses, AI engineering, and more are discussed. It also places a strong emphasis on exploring and addressing ethical concerns, privacy, the issues of bias, both within practice and within AI products as well. So this series of talks and discussions, meetups, we will focus on the role of AI in health tech, fintech, edtech, public services, and also mitigating various risks associated with these use cases. You can find more details on the next sessions and also the previous session we had on generative AI in AgTech on the website, which is hackgeek.com. You can also follow us on LinkedIn and Twitter for updates on these sessions and also other things that we're doing in this space, the whole tech space. So now a bit about Hasgeek for those of you who are new here. Hasgeek is an organization that's building communities in various areas of tech, such as AI and ML, cloud security, privacy, etc. And we encourage practitioners to pitch their ideas for conferences, meetups and groups, etc., which Hasgeek facilitates. So, for example, we're having an SRE conference at the end of this month which will be held in Bangalore. And we also have the Fifth Elephant Conference coming up in December, also going to be held at Bangalore. We also have various meetups going on in cities like Delhi, Mumbai, etc. We've launched memberships so that you can support the communities and participate in all these events throughout India. So about today, we're joined by Bargava Subramanian, who is the Chief Product and Data Officer at 5C Network, and Dr. Praveen Shastry, who is the Head of Clinical Excellence at 5C Network and Head of Technical and Clinical Academics at Manipal HealthMap. They will be discussing the work being done at 5C Network to implement AI systems in radiology. Following this, they will be joined by Dr. Anand Philip and Dr. Hannah Thomas, who are the editors of the health tech track for the AI and risk mitigation project, to discuss methodologies and best practices to mitigate various risks associated with implementing AI in radiology. Feel free to drop any questions you may have for the speakers in the chat, whether you're on Zoom or on YouTube. I'll have an audience Q&A session after the discussion. To Bhargava and Dr. Shastri to tell us a bit about the work that you're doing over at 5C Network.
Thanks, Anvisha. Hi, everyone. Really excited to be here. I'll give a very, we'll give very different perspectives, Dr. Praveen and me, on because I am a data scientist turned a product builder in the healthcare space. On the other hand, he's a practicing doctor trying to implement AI in a setup. So we have very interesting synergies in the kind of stuff that we talk about. I'll give a very quick introduction to what 5C Network is, so that we know that, so everyone knows the context of where we are implementing, and then we can have a discussion. At a very high level, we at 5C Network, we are in the business of delivering radiology reports online. Now, in India, there are more than 1 million radiology reports that are taken every day. And due to some, but we have only 14,000 radiologists to report, which means that there's an acute shortage of radiologists to report. And there have been times when, prior to 5C Network, the time taken to report in many tier 2, tier 3 cities or even remote villages, it used to take like a week for a particular report to be reported, for a particular scan to be reported. And this is something that as a business that we are trying to solve, where we have a network of radiologists, and we connect them with a bunch of hospitals and diagnostic centers where they make, and we do the routing and get the report done. The easiest way I mean, a very trivializing the business, but one way to think about is like an example that we are all knowledgeable about, Swiggy or Uber, where say Uber, I want to go from point A to point B, I take an app, I book. So in a very similar way, so it gets, I book and then I get matched to a driver and I go from point A to point B. In a very similar way, think of the early genesis of 5C network is something along these lines, where there are like all these machines that are out there where the scans are taken, but it needs to be reported. So the scan gets uploaded to our cloud platform, we match to a radiologist who's online, and then it gets delivered. But this was like many years ago, and it has evolved over a period of time where AI is now the core part of what we do, because a lot of the way in which the routing needs to happen, the scan needs to be understood, it all needs to have, you need to have a lot more AI lens to go and then figure this out. I will take a pause here, and Dr. Praveen will talk a bit more about what radiology is and how exactly this process works, and then we'll go and then double click a bit more about the various parts in which AI will be done. Just to set a context before Dr. Praveen talks, is that we'll primarily be focused on AI in a clinical delivery setup. So now there could also be that, okay, how can I work on ensuring that the IT security is in place, how the cyber security policies are in place, are all things that I'm sure there are a lot more people, especially in the Hasgeek community, who are significantly better than us to talk about it. We'll specifically focus on the risks that entails when delivering on the clinical delivery setup, where there's a patient and there's a doctor, and there's a lot more patient doctor confidentiality that comes in, there's a lot more proprietary information that comes in, and we'll just talk in that particular setup. There's Dr. Praveen.
Very good evening, everyone. At the outset, I would like to thank Hasgeek for inviting us for this talk. So yes, I am closely working with Mr. Bhargav since about a year now, and we've been doing some significant work that will add a lot of value to the clinical end. So like, just to give the perspective to everyone who's not from a medical background. So how does this entire scheme of things work? The workflow is as, suppose a patient has a problem. Suppose somebody has a headache. So he goes to a doctor nearby whom he trusts, and the doctor asks for a scan to look into what is wrong with the patient. So he ends up either in the same very hospital or a nearby center. So once this patient goes with a form to the center, what happens thereafter is really interesting. Let's try breaking it down. So first, the first respondent in the entire scheme of events is a technician. So many a time, like in tier 1 cities, we have qualified technicians, but in tier 2 and tier 3 cities in India, because of the large volumes, we have more of trained technicians than the qualified set. So these technicians will actually make sense of what's on the form and what kind of study is to be performed. And actually in radiology, we have a lot of planning that goes into before procuring a scan. So is it a plain scan, which is just taken and then uploaded, or is it a contrast scan wherein you'll have to inject a dye into the patient, time your study accordingly. We'll have to wait until this contrast reaches a specific organ. And during that moment is the organ lighting up. So there's a lot of science around it. So the technician out there has to plan the study and then procure the images. And once the set of images are procured, there's a bit of post-processing that goes into. And then finally, once the entire set is stacked up, it is uploaded to a platform like 5C with the proper history. So after this, what happens at 5C? It gets routed to the available radiologist who is best suited to report such a scan. So we might have a general radiologist on the platform. We might as well have a neuroradiologist who subspecializes in interpreting brain-related scans. So it goes and gets routed to the most appropriate person there. And now I would like to give you the radiologist perspective. Now I'm on the platform, a case is allotted to me. My thought process is first, I ensure I look into the history first to know what to look for. So history is of paramount importance out here. So my entire, like every case to a radiologist is a Pandora's box. It is a mystery to be solved. So it's fun. So, and before I get into it, I must have a rough idea about what to look for. So history is very important there. And then I get to the sequences. So if it is CT, it's a straight cut case. If it's MR, we have a lot of sequences to go through. And then once I'm going through it, I have a kind of theory as to what might have gone wrong. And it's a straight cut case wherein I don't have to refer anything. But once in maybe 10, 15 cases, I might have to, if that's not routinely encountered a case, then I might have to just refer to the text, to my textbooks or authentic material out there on the net. I just refer to some material and then zero in on my diagnosis. After I've narrowed in, I'm sure of what the diagnosis is, the radiologist has to generate a report. It has to be structured. There has to be an acceptable template in which the report is generated. And that report is uploaded to the platform. And the platform sends it across to the site in which the patient is. So this is the entire, to say, physiology of how the radiology, teleradiology thing works. And it gives me a lot of pleasure to say we've actually done quite a few things, which we'll be elaborating in subsequent segments. That has actually decreased the time required to first thing, it has actually led us to procure, it has helped us enable the technicians procure scans in the most appropriate way, one. Second, it has actually helped us to route the scan to the most appropriate person on the platform. Third, it also helps the radiologists make apt decisions. And finally, it is also helping the radiologists generate reports faster. So accuracy and time, both are the positives of what we've done. I think we'll elaborate it on subsequent segments.
Bhargav, is there something that you want to add on at this point?
So, I mean, just summarizing, or my way of understanding what Dr. Praveen told is that so the scan comes, it's taken at a particular center, so diagnostic center or hospital. We have a bunch of suite of AI products that enables the scan to be taken in the appropriate way and in a fast way. And then once a scan comes, there's a whole bunch of AI that is done on that particular image to prioritize and also to send it to the right radiologist. And when the radiologist looks into the image, the two things that happens, it helps the radiologist analyze the images faster by pointing out, for example, if you take a particular CT or MRI, it can be as much as, depending on the slice of the machine, it can be 250 images to 1,000 images. So pointing down to the exact place where there is a finding is a huge time saver, one. And then once all the findings are done, how can they synthesize the reports faster? So there's a whole bunch of LLMs that we have that enables them to write reports, craft reports faster. And then it gets delivered to the place where the diagnostic center or the referring physician or the patients are. And that's an entire bunch of routing again that happens. So three kinds of workflows, and then there's an AI in every single workflow that touches this particular surface area.
And Vishy, can we?
Yeah, go ahead, Anand and
Okay,
Hannah.
fantastic. Yeah, okay. Right. So, Hannah, do you want to maybe take this?
Yeah.
Yeah.
So Bhargav, you said, and Dr. Praveen also, you said, the images get routed to you. So one of the questions that I have is, first thing is about how does the data come to you? In terms of, with the clinical history and with the patient imaging. So is there a system where you have in place where the data is anonymized at source, or it comes to your 5C platform and then you anonymize the data? So I'll let Bhargav take that first.
Yeah, I'll take this question. Yeah, thanks, Hannah. Fantastic question. Okay, so now there are okay. It opens up some amount of legalities into it, right? So now, I mean, we all work in some parts of the healthcare system. So this is for the wider audience, so you understand. Consider this fascinating case, right? As a patient, I have some problem, stomach pain. I go, I meet a gastroenterologist. He or she touches the stomach, looks into us, and then write the medicine, right? This is a very common workflow that happens in India. And there is no documentation on why this is done. So the patient goes with some symptom, some result comes, right? This is a very common symptom that happens where the input is the patient going and telling something, and the output is just a prescription slip with the medicines that happens. It's very different in a radiology setup. A radiology setup, the input is a scan, the output is always a record. Now, it's very debatable stuff in how it happens in India, but primarily because of the immense pressure that that doctors go through. So both Dr. Praveen and Anand can attest to this, that immense pressure. The workload is insanely high. That like at this point in time, the doctors are legally liable for the report that comes in. So the doctor should know the patient he or she is treating, to the patient for which they are writing, right? It's impossible to accept that you just take an anonymized thing, right? And then, but you're also liable legally. It's not a case that will fly, right? So in that part, in that particular aspect, the doctors, the radiologists who report will have access because they're legally liable for anything that happens. So this is one interesting challenge that happens specifically in an online remote tele setup. The second thing is, we just discussed, so there's many multiple moving parts. So the machine is taken at a particular machine, right? The scan is taken at a particular machine, and from there it flows into multiple parts even within the hospital network before it comes into our cloud system. So there are two ways in which the anonymized. So the answer is the data is always anonymized until it gets to the doctor, and depends on what the setup is. It could also be anonymized with the doctor, but the anonymization is only purely on PII data. So which means that a combination of the data that can uniquely identify a customer a patient will just not be available. So which means that the doctor, the radiologist, when they report, he or she will need to know the gender of the patient, will need to know the age of the patient, because that matters a lot on the kind of the symptoms, and the scan will equate to some finding based on the gender and the age. It's super important, and the location from which he or the patient has come. So that is super important. But to do that, we take certain set of anonymization. For example, name is always anonymous. It's always some pseudonym is provided before it's fed into the system. And that's always done at the source, not at our end. So at the source, we have a software that anonymizes, that pseudonymizes into a different name, and that comes in. The second part that happens is in terms of age. Age gets split into bins. So into a reasonable bins that we work with a whole bunch of radiologists, which Dr. Praveen defines on what is an acceptable limit. For example, 10-year range just doesn't work in medical history. So that the change makes a huge difference, right? Which is what I used to do back in my day until I entered into the medical industry. I'm like, oh, 10 years doesn't make sense, is it? So they're all like smaller bends, sometimes 2-3-year-old bends to do it. The third, so pseudonymization and then bins for the age are two things that happens, and pretty much all of the other things come. Most of the times when the doctor looks into it, they need prior reports, scans, so which we call it as clinical history that needs to come. At that point in time in the entire flow, until it hits the doctor, it's encrypted, and then the doctor only can view it, and then they can see it. Obviously, one could just go and then obfuscate the entire header or the footer, but I can tell you, just doing this field, we've done more than 7.5 million scans. No two history are the same. Okay, it's a challenge. It's a genuine challenge where there's no standardization, there's no electronic format. At pretty much a lot of time is just take a phone scan and then upload it on the platform. And so a lot of time is just encrypted before it goes to the doctor. So there's no one who will be able to look into it. So that's the flow on the name, age, and the clinical history that falls into it. Why, you might ask, why are we not anonymizing and pseudonymizing it? It's a very Indian cultural stuff. You want a name to be given to the patient and call. You cannot call, oh, this number ABCD. Like my first job was in we used to do production 24/7 production support. We like K as in camel, B as in, so we used to do calling to the US. It just won't work in Indian setup. We need a proper name to call, and so a pseudonym is important in the cultural aspect of working in Indian market.
Yeah. Thanks, Bhargav. Anand, do you want to go?
Yeah.
Yeah.
So I totally get the, needing names and, needing some kind of continuity in, being able to identify the patient and things like that. So maybe we can sort of specifically talk about yes, Dr. Praveen, you wanted to say something.
Yes, sir. I would like to take the liberty of explaining the same with a few examples. So, knowing the history in toto and knowing the age of the individual is non-negotiable. It is a must. And just to elaborate it to the others, so the place where the scan is taken is of immense importance. Suppose a patient comes with something called as encephalitis, fever with seizures. That is called as swelling in the brain. This encephalitis, if it is there, if it's somewhere from North Karnataka, it's an endemic area for Japanese encephalitis. So we have to look for hemorrhages. So the site from which the scan is procured is of very high importance. If the scan is, suppose a patient comes with limb edema, it might be a deep vein thrombosis or a cellulitis. Apart from these two, if the scan is from Bihar or Kerala, it might as well be filariasis, which is endemic in those areas. So the site is also very important. So even before we open the scan, knowing all of these will give us an edge. But more often than not, we'll have to work with suboptimal history. But then we've tried streamlining it on 5C, as in what we do is we have actually streamlined the process wherein before the scan gets accepted into our platform, there must be proper and adequate history. We have come up with the most necessary history points for each kind of case. Suppose, let's say, a thorax case, a chest case is uploaded, CT thorax case is uploaded. So we have 5 points that has to be there before the technician at source is uploading the scan. So we need to know about history of smoking, if a patient has had tuberculosis in the past, if the patient currently has fever. So these are the things that are a must know, because white bands are all that we see. If it is a chronic thing, it becomes fibrosis, and if it is an acute thing, the same thing is called a consolidation. So duration, site, gender, age are absolutely non-negotiable. So
Yeah, that makes a lot of sense. I mean, yeah, I mean, you cannot really have a context-free clinical process. You need the context. Yeah, that's, I think, clear. So you've actually already spoken about this a little bit, but I wanted to ask both of you if you could maybe step by step talk us through some of the technical safety measures that you have in place. Now, as far as I can see, having a basic checklist for making sure that essential history is taken before a thorax CT is done is a safety step. I mean, it's got other utilities, I'm sure, but I think it's a pretty important safety step. So what are some of the other sort of technical safety measures you've got in place at different stages? So you've got the pre-workstation stage and the workstation stage and, post that. So, yeah.
Okay, so maybe we'll split into two parts. I'll talk about on the systems, and Dr. Praveen will talk a bit on the clinical side. So from a system side, we talked about, there is always encryption that keeps happening. All the best practices, the keys are rotated regularly. We no unauthorized accesses, VPNs. So interestingly, one of the challenge, specifically if you work in radiology, compared to, I mean, a lot of medical companies also work on EHR versus in EHR versus radiology. The only problem is radiology is like 1,000 times more data. The storage is so high, right? And we like every day we add a few terabytes of data. So adding so making so I think we have a very genuine cloud strategies, making all the cloud providers rich. So that's like a way where it becomes a very difficult problem. That used to be the case before we now started working with colo hosted. So the data has to reside in India. That's something that we've been very conscious about. So none of our, or I mean, for Indian customers, it resides in India, and we do work with a number of international hospitals too, and it always resides in that particular server. So how it happens, where it happens, how do we ensure it, makes a very big sense. In general, in India, we've identified a set of partners where colo works really well. Private cloud, it specifically caters to our needs on data storage. International, at this point in time, it's primarily split between the three cloud vendors. It's easier just for us. It's just that we know that they're all like GDPR compliant, HIPAA compliant, and easier for us to do right now. But the encryption, storage are things that, and also there's a lot of transmission that keeps happening, right? So how do we ensure that like every image. So one of the interesting things I talked about prescription coming in a pad. On the other hand, radiologists are at the forefront of technological innovation in the medical industry, because they've always been the first to adopt technology in the healthcare space. And so a lot of things are always natively digital. So how do we ensure that all the privacies are in place? For example, a lot of things, so we used to have it earlier, but at this point in time, our entire reporting, for example, yeah, we cannot do it in mobile. We took the conscious decision that reporting can be done only in a large screen. So we check for the screen resolution, because it's like if the site can open, the site can open on a mobile phone also. So how do we ensure that the platform works only on web, but while for the patient will need the scan both on mobile and on web. So how do we ensure that two different ways can we support how the images are transformed and can be viewed? So those are things that we take a lot of effort in optimizing. So those are some of the things where and on all the links expire at after a particular span in time. So those are things that took us some time. It's just that because we work under multiple geographies, we need to ensure that we need to follow the land of the law. So we need to ensure that we follow the policies in India, in Middle East, in North America, in Western Europe, in South America. So it makes it extremely challenging in some of the laws being very conflicting with each other and what needs to be done. So at that point in time, it's Herculean task, but we are able to comply with laws of all these geographies. Doctor, do you want, Dr. Praveen, do you want to talk a bit more on the technical safety specifically?
Yeah, especially from the clinical point of view,
Sure,
when
sir.
it comes to, the imaging.
So I would like to take this question and answer this in two different axes. One, the importance of history that we've already discussed to a certain extent. Second, we've actually kept a check on the basic number of the protocol to say. So again, I would like to elaborate with an example. So suppose a patient is a suspected case of cerebrovascular accident. Suppose, let's say, a patient is suspected to have a stroke. Now, what's happened here is one of the blood vessels supplying the brain is clogged, and there is no adequate blood supply to the specific site of the brain. Now, to confirm this, the treating doctor has asked for an MRI. MRI scores over a CT here, so they've asked for an MRI. And on MR, what we as radiologists expect to see is a sequence called as diffusion weighted imaging. So if the site, the expected site, lights up, if it looks bright on a diffusion weighted imaging, I know that is a stroke. So this is the context. Now what happens is diffusion weighted imaging is taken as a single sequence, which is a very short, less than a minute kind of a sequence. It is split into DWI and ADC. There is minimal post-processing involved before it is handed over to the doctor. And that is when it becomes interpretable. Okay. Now what used to happen, if not for these checks, is the scan used to be uploaded on the platform. It used to have been routed to the doctor. The doctor finds that the post-processing is inadequate and the scan is not interpretable. Now it goes back to the platform and then back to the center. Now the post-processing is done and this correction is done. So in this entire scheme of things, this Chinese whisper takes a significant duration, at least some 10 minutes. And to just give you an overall perspective, that is one limb permanently disabled. Time is brain in cases of CVA. So to prevent things like these, what we've come up with is we have one step, a set of norms that have to be followed before a case is routed to the doctor. This is actually extremely beneficial, wherein right at that very step, any problems with the history, any problems with the sequences are flagged and corrected so that this rerun is prevented. That has actually proven to have given results and has helped a lot of patients.
Yeah, Dr. Praveen, just to nudge you a little bit based on, so you said, you have these checks in place where you say, okay, you need a minimum number of, so just to put in perspective, do you have the minimum data points for each scan in terms of both clinical and imaging that is specified upfront to the client before it comes to the clinician? Yes, its time is of the essence, but that is before it reaches the clinician. But still you have it at the technical point, there may be a rerouting that's happening. So how do you, initially probably you would have had those issues that you have mitigated. How did you ensure that? So, this back and forth was reduced. If you can elaborate a little bit more on that.
Sure, ma'am. Thing is, we know for sure that every scan has a crux set of images. So before we accept that, suppose now let's elaborate on the same very example that we've dealt with so far. So in a case of stroke, we actually we have a bot that ensures, asks repeatedly, probes the technician who's uploading the scan if there is ADC and DWI before it is uploaded. So if there is history of stroke, we have to have these two. If there is history, like specific set of indications need a specific set of sequences. Suppose they expect to see bleed, we need something called as a SWI sequence. So like these, we have most important sequences without which the scan won't even be accepted into the system. That is one. And adequate history is a must. If these history points are not, so the system is so structured that only after all these boxes are ticked will the scan be accepted into the system. So that was the most efficient way to counter the problem.
So that actually allows a lot of these diagnostic centers also to have a minimum baseline that they are maintaining. So all of your partners to some extent understand these are the minimum number of things that need to be addressed before it can get reported. So
Yes,
in
ma'am.
a way, you're helping with that standardization process, if I may say that.
Very true, ma'am. Very true. That's the best. But it's an ongoing war all the time. It's like we're never there. The thing is, these are points without which we can't do it. You cannot report a case without these sequences. We are just there. But the idea is to equip everyone, and that is the greatest challenge. Like, thanks for you to bring this up. Thing is, problem with Indian cohort is that there is a very wide spectrum that we have to cater to. We have a zero point 0.3 Tesla machines and we have a 3 Tesla machine. Likewise, for CTs, we have a dual slice or a single slice machine and also a 128 256 slice machines. So the problem with handling these is it is a problem at every step. The number of images that you get on a dual slice machine would be say 10. Whereas for the same study, same part, the number of images that you get for a 256 slice machine might be 76. And even to the doctor, if he's used to reporting 3 cases of a 3T machine and then he suddenly has to see a case from a 0 point 0.3 Tesla, that it's a challenge at every point. You can't expect the doctor also to give an equally competent report when this is there. But then that's a part of the game. We'll have to do it. And we are trying. It's an ongoing process. We are also iterating. So, but then indirectly we are trying to help. And one more thing, like I'll just take the liberty of explaining on that as well. We have something called as protocol bot, which is introduced. So this is a interactive bot mainly designed for all the technicians. They can actually come up with a question and get the best possible sequence and the most appropriate way to plan a given study. So that is something, that is the AI tool in place to ensure that there are safety standards are met to the. So
Cool. So you mentioned that you've mentioned a couple of bots already, and I know that in the marketing and all of that of the company, you kind of talk about AI a fair bit. So how has sort of been the reception to talking about AI, and how has what are the challenges or pros of saying we are AI people when you're working in the clinical community, both with technicians as well as clinicians, and yeah. So what are the people challenges?
Again, we'll take two different angles. And then I'll probably go first. So think about the practical setup. A patient goes at that point in time, somebody needs to be there to take and then guide the patient into the center chain, and that's a lot of things that the technician will do at that point in time, right? All the tools are just enabling him or her to do their tasks better and faster. So it's not a replacement for them. At this point in time, really telling that except us, there's no one who's really built any tool for the technician. They're all finishing their bachelor's or diploma, and then they get started. And then even upskilling is a Herculean task, primarily because I mean, unless someone really goes to a diagnostic center, they would really not be able to tell this, because it's extremely long hours. You cannot tell, oh, my 8-hour shift is done, I will walk out like a software engineer, because there's a patient out there who, if it's not scanned and treated right now, probably could die. So they're extremely sensible and sensitive people, and are at the forefront of what is happening. So at that point in time, a lot of these tools only help them do their tasks better. That's one. Also remember, they're all working under very close proximity to radiation machines. So they already need to take a tremendous amount of safety before they operate. So all these tools that enable them to get better is super useful and important. As much as we talk about scarcity of doctors, there's also not enough technicians in India. That number is also less than 1 lakh in India. It's not like that number is huge. So for all the machine that comes in, we have scarcity of doctors. We also have scarcity of technicians right now. There are very few programs, and that's one of the reasons why Dr. Praveen himself is heading a technician program for Manipal Hospital. So that's something that is super important. The second aspect is in terms of radiologists, right? So that's one part where the technician at the source, and then it comes to the doctor, the radiologist, and they're always under pressure, because we just talked about it. It's not like so the way it works, say in a US setup versus Indian setup, are very different. In India, we need the reports done faster, quicker. US, for all the amazing things, still liability insurance is what drives a lot of the market, and so it takes a very long time. Really, I'm not here discussing which model is good or not. Any patient should be given the best possible care, right? And we are in the business of doing it. At that point in time, any productivity tool, anything that can help them automate and augment it, is super important. I can stick my neck out and tell that there is no way that AI is going to replace a radiologist, a doctor, or a technician, or anyone in this ecosystem. It's just going to make things better and faster for everyone in this ecosystem. And then the third part, so once the report comes, the third part is ensuring the correctness for doing all of it and then sending it, right? At that point in time, it's also super important that a lot of checks and balances are done, and then there's an AA that goes and then validates it and then delivers it to the physician, to the diagnostic center through an automation tool. And that's also super important, because you need to ensure that quality of thing is placed. I would tell a very common example. So like you might have seen it, and you might have seen it a number of times, but like this is very common. The way a radiologist would write a report is that they would already have some templates. No one is going to write the entire 2 pages right from scratch. It's already some template that they're going to take and then write, right? So a very common example is for a male patient, they first type out for some disease finding that they find as a template that they already have. It might happen that that's a female for whom the doctor would have reported earlier. They take it, they paste it, and they go and describe very detailed the first 4 lines. And then they're like, oh, I'm so focused on ensuring that the finding is correctly described. It's done. Click submit. Now what has happened is there's a whole bunch of text that's below it, which the doctor has missed deleting it, right? This is a pure clerical error. The doctor has been so focused on getting the right report out, but the bottom of the report has the uterus is normal. Okay. It happens so often that it's not a joke anymore, right? And the report is so correct. It's telling a statement that the uterus is normal. The patient goes off. It's like, what the heck? This diagnostic center is not correct. They see one thing, I am a male. How is this happening? This is entirely wrong. The report is wrong. The doctor is wrong. The center is wrong. The social media is now filled with outrage, right? We are very good in doing that. So the problem is, this is a problem that is well suited for technology to solve, right? To tell that this is something that the doctor is under immense pressure to do so many things. And if you've ever seen a radiologist report, you would know that the radiologist is reporting, and there'll be like 10 calls. Some calls are real emergencies, some things are social emergencies, telling, and then all of these things, and they just need to go and then solve all of it. It needs to be solved, right? So these are places where AI can really come and then make a huge differentiation, right? So so that's something that I would say, have Dr. Praveen will add some more flavor to this from a clinical side.
So yes, so coming to AI implementation challenges, what first thing I would like to emphasize on the fact that we are firm believers of AI as a tool. So there are three approaches when it comes to AI. AI as a replacement approach, AI as a triage approach, and AI as an adjunct approach. So we believe strongly in the philosophy of AI as an adjunct and a triage, and never can it replace a radiologist in toto. So that's our belief, and that's how the entire work that we do is built upon. So why is it so? See, first thing, coming from the clinical perspective, implementation of AI, first thing, the challenge is the mindset or the attitude towards AI. So there are radiologists who still feel threatened that their jobs are at risk because of uh, advancements in AI, which I personally am not a advocator of that philosophy. And because of that, hitherto, radiology was top one. Now that there's a lot of buzz and it's not held on to the first spot even now when it comes to post-graduation seat allotment. So there is a challenge there. The acceptance of AI is still a challenge when it comes to radiologists as a community, first. Second, inhomogeneity is a huge challenge. Like we discussed, inhomogeneity when it comes to the devices over which the scans are procured, inhomogeneity as in the knowledge of the technician taking the scans. So this inhomogeneity is a parameter which is very difficult to address. So implementation of AI and also building tools to say, let's try for a triage, we'll have to build a tool. So again, I'd like to go ahead with an example. So there are cases in radiology which needs attention at the earliest. Suppose this condition called as pneumothorax, when there is air between the lungs and the thoracic wall. So if we wait any further, the affected side of the lung will start collapsing. The patient won't be able to breathe. So that is a very, very important emergency. One. Likewise, if there is bleed in the brain, the longer we wait, the more brain parenchyma we lose because of mass effect. So these are conditions which need immediate attention. So we've actually built tools, and there are only a handful of these. Not every condition is an emergency. So whichever demands the attention of a radiologist at the earliest, we have actually built tools to flag these cases to the top of the list. So that is another thing. I just wanted to talk about that for now. But challenges from a clinical perspective is acceptance of these tools, and again, the inhomogeneity or the spectrum that we'll have to cater to. That would be my clinical perspective to this question.
I think keeping in line with what you just said, I'm going to take one or two questions from the chat as well. So we have one question where, how does insurance companies support teams because they need to know who the doctor has reported? So I assume that all your records will have the reporting radiologist's name. So
Yes.
so
No
here,
radiology. Sorry. Please continue. Sorry.
no. So all radiology report will have the reporting radiologist name. The question is, then what happens to privacy? Here, privacy, I assume we are talking about patient privacy during the reporting. or do we also have privacy in terms of the report from the doctor?
Ma'am, what I was asking is, can
Yes,
I just
please.
rephrase it? Yeah. What I was asking is there are a lot of doubts which insurance support teams have. They have to clarify with a doctor. Like I am referring to, let's say, patient A, which you had reported, but doctor is like, I don't know who patient A is because it was a pseudonym that they followed. Okay. Second is um, the history. Many of patients hide histories so that they want to get insurance. If they have a previous history of certain diseases, then insurance companies usually avoid giving insurances. So how do you tackle all these complexities?
So this is okay. Very good question. So Manu, so typically this is handled on the hospital and the TPA ideally, right? So if the only so we provide radiology reports. So if there's a question on the radiology report, typically the hospital center would call our technical support or customer support and tell that, oh, this is something that's the query has come up and we need to have a discussion, and we will have this discussion with the reporting doctor, with the hospital. It's never with the insurance provider. There's always the physician, the surgeon. There's the person who always decides and would be doing it, and in a typical setup that would be coordinated by the TPA. So that's always a setup.
So yes, so any queries from the insurance team will go to the treating doctor. And only when the treating doctor is convinced enough that there needs to be a discussion, he'll be routed to the reporting radiologist. So it's again a two-step process. The radiologist would not have the luxury of time to interact directly with. So that is one thing. And this encryption of data or the name is handled at the hospital end. So we are not worried. Even when the query comes, the doctor is pre-fed with the set of images and he'll have a look and discuss with the treating consultant live. So that answers the question.
Yeah, I understand, sir. Thank you. And also, is there any a quick add-on? Is there any cases where you have to directly report to the government in certain diagnostic scenarios? I mean, we saw it with COVID, for example, but I don't know if in radiology it is there. So how do you handle it?
Excellent
All
question,
scans
sir.
are radiology scans. Okay, can you clarify the question? Reporting to the government. What do you mean by reporting to the government here means?
So I think I kind of got
If
it.
you have, for example, yeah, sure.
Yeah. So the thing is here, we have a set of cases that are called MLCs, medical legal cases. May it be an attempt to suicide, may it be a road traffic accident, a case of assault. Unless proven otherwise, all of these cases are considered to be a medical legal case. So the doctor is liable for any statement that he puts on paper when it comes to these cases. So like government, I mean to say the court of law. Yes, I am liable. And if there is a summons issued to justify my statement, there are many instances wherein the radiologist is as well summoned to the court of law.
Okay, sir. Thank you. I'll
Thank
ask for
you.
follow-up questions on the chat, but thank you.
Sure, sir. Thank you.
Just one more question, because we're dealing with the people challenges. One of the questions here is it cheaper for radiology centers to use 5C network than local doctors?
I have very valid question. Actually, see, this is actually a very that's a good question to say. Suppose I'm running a center, a diagnostic chain to say. I have two options. Either I'll have to hire a radiologist on site, or I'll have to resort to solution providers like 5C. Now, what do I choose when is actually based on the caseload that I'm encountering on a daily basis. Suppose I have enough and more cases to keep a radiologist occupied full time. Such centers actually go ahead and hire one. But just in case I'm doing less number of cases, then it would not be economical for me to hire a full-time radiologist who comes at a cost. So such kind of cases, tier 2, tier 3 cities, wherein a radiologist would not be comfortable settling down. So these are the centers who form the major chunk of our customers who need reports at a faster pace and accurate.
I'll add two more layers of complexities here. So one is the PCPNDT Act in India, which mandates that only a radiologist should do an ultrasound scan, right? So Dr. Praveen is an expert radiologist who spends a lot of time doing ultrasound scans, right? So that's the nature of the business. And so when X-ray, CT, or MRI is done, it takes there's just not enough bandwidth for the radiologist to do it. And so even if the center has enough radiologists, they would always need to augment with providers, and that's where players like us come in and doing it. So at this point in time, it's not a discussion about cost. It's a patient's life at the other side, and so it's a whole host of situations that matter before this comes in. So that's one set of point that really one needs to consider. The second thing is like there is a specialization in radiology also. Some radiologists are very good in neuro, in head neuro. Someone is good in heart. So as a patient, you need the power to be able to be your scan to be reported by a radiologist who's a specialist in that particular field, and that's something that we provide, right? So that makes a big differentiation. If there's one radiologist be stretched doing ultrasound and 100 other kinds of scans, while area of specialization is something that we can come using power of AI, right? So AI really makes a big difference in building these subspecializations in radiology.
Okay, we will get to the other questions also. But I kind of quickly wanted to, so a lot of what we've discussed so far are, the protocols and processes and checks and balances you have in place to deal with the people error and to deal with some kinds of technical problems that can come up, in this whole process. Could we maybe speak a little bit more about the algorithmic part of it to, what are your, approaches for algorithmic safety? You've got images coming in from a 2-slice machine to a 256-slice machine. What do you have? Because, if you've trained on a certain type of resolution, it's not going to generalize well to other types of resolutions. And similarly, you've got chatbots going on, doing generative stuff, hallucinations, all of these. So maybe we can focus a little bit about the algorithmic safety part of things and, where you see problems and risks and things like that.
Fantastic question. So I'll take this question, Dr. Praveen. So there are two broad areas, as you rightly pointed out. One is when a scan comes in, we need to identify what problems are there in the particular scan, what diseases are there. So that's all done by the computer vision models, right? So there's a whole bunch of computer vision models that we do. One big advantage is we've been doing this for, we have scans for the past 6-7 years, that we have more than 7.5 million scans, and we have seen such a huge variety of scans that are ever possible. X-ray, CT, MRI, PET scans, all of it we have seen, right? So we have seen right from a single slice machine to a 256 slice machine in CT, and we have seen we have probably the largest collection of 0.3 Tesla machine images in India, to all the way till a 3 Tesla machine. On average, just to give you, in India, 32 slice machine is the most common in 8 to 32 is the most common in CT, and then 1.5 Tesla is now becoming the norm in MRI. But the kind of images, no one really replaces a 0.3 Tesla machine for a number of reasons. Because, for example, the patient does not want to go into they get claustrophobic, they don't want to get into entirely enclosed ones. So there are reasons for which different kinds of scans exist. And in this particular setup, we have seen so many different kinds that when a particular data comes, this image is called DICOM image. So DICOM is the standard protocol on which medical images operate. The medical image format is called DICOM, DICOM. It's got metadata which talks about what machine in which it is done, right? So there are two kinds of problems. One is two kinds of things that you need to know. One is what kind of machine it is, and two, we also need to know, as Dr. Praveen told, what is the location in which it is taken. So that is super important, because the disease predictions have to be biased based on the location in which it is. As he rightly told, that certain diseases are endemic in certain areas. So we need to know where it comes in, so that the models are tuned to that particular stuff. And that's all handled at a place where we get this information, we extract the metadata, and then the corresponding models are called. So it is no one model that provides the output. It's a cascading set of models, right from understanding. So there's a lot of challenge, right from understanding if the report, so for example, someone goes to the machine and write a console, then telling that this is a CT of a brain, but then they take a CT of the chest and then provide. We first need to start even understanding that is it the right image, the image name and the images, do they even correlate or not? We need to build some basic classification models to even start then identifying what diseases are over there based on the machine, based on the location, based on the history. So that's all on the computer vision side. So there's a whole bunch of model that's built. It's so, for example, one prediction could for example, something very complex like a chest would probably call for about 250 models to be predicted before it even gets to the reporting stage. So it goes through about 250 models, because there's like a whole bunch of things that needs to be done. One could be just a classification model. There's a bunch of object detection, and then there's a bunch of check again on the stuff that comes in. There's a bias on where the location comes in, and we need to have a different set of understanding of it before it finally enters into the LLM part of it. So that's on the computer vision side. On the LLM side, obviously, when we started, we used standard deep learning NLP based techniques, and now in the past 1 year, with advances in all generative AI, we are entirely LLM based on the reporting side, and that would require us to both do bot query answer and also be able to draft a version of the report, right? And that requires, so we have a history of 7.5 million scans. We've seen various kinds. Now, the common kinds of, the three common kinds of problems. One is standard description of how it looks like, but there are two other variants that comes in. One is a hospital might tell, my reports need to look like this. And then there are doctors who will tell, my reports will look like this. So we can have a doctor level input. Hospital or diagnostic center wants a particular standardization and a very standard way on which that particular disease has to be described. All three are handled at the LLMs. The way it is done is that we set the temperature low. We have guardrails in place. So temperature is a way where if the temperature is high, there's a lot more hallucinations in the report that comes in. If the temperature is low, there's not much hallucination, but it also means that we need a rich history of, if we don't allow it to hallucinate, then we need a rich history of rich repository before it can be used for training and fine tuning. Those are all things that we actively do. And there's like strong guardrails that look for it, and then checks and balances to go and then fix it.
One point that I'd love to add here is looking at half glass full approach. If a solution can work on Indian data, we've conquered it all. So given all these challenges, if something can work with Indian data, then it's for sure, it's very good globally with a great accuracy. Right. So
yeah, I think you asked about machine stuff. There's also a fundamental premise in which why we started building our own homegrown AI models, right? One of our interesting experience have been that a lot of the AI that's on radiology has been built on either a Stanford data or very clean data that's taken in the Western world. It's not something that happens in India. It's like 95% of the scans don't follow in that particular step. So it meant that we really have to invest very deeply in building something that caters to the Indian standard of working, which is now at the pace at which we are going, we are India's as India, we are the largest, we take the largest number of scans, and we process at 5C, we process the most number of reports in the world right now. So it gives us some edge on the kind of models, the way we can think about doing all of it. So those are the things in which we ensure that the algorithmic safety are there. So I think I'll need to add one more thing in terms of, okay, but there could always be false positives or false negatives, and how do we go about handling it? So interestingly, we retrain the model every single day, because we process so much volume that we retrain our model every single day. Right. So at some point in time, there's always something that gets flagged. If something is less than a particular amount of probability percentage, the precision or recall is very different from, for example, because we give a prediction. So you might ask, okay, but how do you get the data, right? Like okay, you predict, but how do you get feedback? Because you always have to remember that radiologist is in the loop, right? So we have a very active learning framework where from the report we also know what the radiologist has corrected or reported, and we always have the input that fed back, and that goes and then updates the models. So that way we know that tomorrow our models are better than the models that are there today. So we ensure that keeps happening in the computer vision side, because there's always a new pathology that comes in. On the LLM side, this is like, once we understand the use case, once we know what needs to happen, there is a fair amount of standardization on what needs to happen. A lot of the challenge primarily comes on the computer vision side, because new pathologies need to be added, the machine is different, and images can be distorted. There's a lot more thing that needs to be done.
Okay.
Anand, I'm just going to go ahead with a follow-up question on this. So here we are talking about, sometimes not clean data or suboptimal data in some sense. So how do you ensure the validity of the report when that scenario presents itself? So are those caveats mentioned in your report, or how do you handle that?
Dr. Praveen, do you want to answer this?
Yes, ma'am. So whenever there is suboptimal history or suboptimal images, we make sure that it is drafted right on the report. It must be documented on the report itself. Meaning to say, suppose the consultant wants to know if there is some pathology, let's say confined to this bone, which is maxilla, and the patient has a tooth implant, which is metallic. Whenever we procure a CT in such a case, we will lose out on a field wherein the consultant wanted data about. So braces will like make us lose data on the surroundings. Likewise, there are a lot of artifacts in the images. So we make sure just after the history, we document that the scan is suboptimal secondary to X and Y kind of artifacts. There might be the artifacts again are of different types. It could be because of patient end, meaning to say it might be because of patient movement, patient motion artifacts. It could be technical related, and it could be post-processing related. So if the critical points are lost, we make sure that it is documented in the report, because it is a medical legal document at the end of the day. So it needs to be addressed.
So I'll just add a point to Dr. Praveen's statement. So within 15 minutes, there's always, with so many cascading models, it does take some time, but within 15 minutes from the time the scan is done, we would be able to provide feedback to to the diagnostic center about what the status. So sometimes if we need, for example, as doctor told earlier in the session, we probably need to take more sequences. That's something, if something is missed, we'd be immediately be able to flag and tell that, oh, okay, this is what we see, just go add more sequences because this is important for when the radiologist is going to open. These are all the things that immediately needs to be done. So that's an immediate feedback that 15 minutes is not immediate, but it's immediate enough that feedback goes in. Because a lot of time what happens is that the patient comes, the scan is taken, and the patient is back. And then if these things are not done, they will not be able to do. So there are, this is one in terms of number of sequences being there or not. The other big challenge is that we the artifacts, the suboptimal images that comes can be of three different categories. One, as doctor told, one could be because the patient is going through immense pain. No one wants to, I'm happy, let's get into a scan machine, let's see what comes out. Is not what it is, right? Someone, say for example, someone has a fits, epilepsy, they go in, you're going to see a lot of movement, right? So that's one thing. It's critical, it's emergency, it needs to be reported. There is no way to go, we'll do it when the patient is stable, is not the answer over there. On the other hand, the second, so this is a place where we mark, it's automatically added into a report and then is sent telling that motion artifact by the patient is seen. There is a second set of problem where the machine might have some challenge, right? So a common challenge is to see ring artifacts in the machine. So you know that whenever the machine comes, there's always small ring dot that keeps coming in. Not too common, but not uncommon also. At that point in time, we have AI to know that, oh, this particular we have done this analysis to know that this particular center, this particular machine has a ring artifact. And so let the reporting radiologist know that when something like that comes, it's a ring artifact and not something that they should be thinking about for mistaking it for a disease finding. That's the second thing, right? The third thing is, so there's a machine problem. The third thing is, in general, people problem, right? Like it's just not taken properly for whatever reason. At that point in time, which is why one of the reasons why we introduced our protocol bot, because it helps coach the radiographers, the technicians, telling that this is how it should be taken, and there's like an active upskilling that happens. So three different parts. The third part can definitely be solved with better training, coaching, skilling, which is something that as a generative AI tool, we have a process in place. The first one, it doesn't matter. That's a patient problem we really need to solve. The second one is something that we have AI to tell and bias the models on what needs to happen. So ways in which we handle this at source.
Okay, thank you. So I'm going to quickly maybe ask a couple of questions that are in the chat so that you can answer them, because yeah. So are there any specific types of scans that make up the majority of cases? You know, is there something, you know, like that? And is it cheaper for radiology centers to use 5C network than local doctors? I'm not sure if, yeah, that's a risk-related question, but yeah, okay.
We already discussed that about using 5C, but I'll start talking about what contributes the spread of
I think that would
radiology scans in India. So X-ray dominates, then CT, then MRI. This is all over India, and then PET scans, which are small in how it's done. In X-rays, chest dominates. So on 50% of all scans taken in India are chest X-rays. And that's not.
We love chest X-rays.
Like that's primarily because it's also a screening tool. You go and get a master health checkup, chest X-rays are done, but it's also that TB and pneumonia are very popular in India, and this is like one major screening tool that is used. Some statistic in 2022, 223 million Indians were screened for TB in India. So that's like the statistics. So this contributes a huge number in terms of what's happening. But that's all like, so one way to understand chest X-rays are just one glorified JPEG image. So there's a lot of things that can be done easily using AI. And then you go into CT and MRI, the complexities increase because CT you just have more series, and in MRI you also have sequences and then series. So a lot more challenges that happen as you go from a single X-ray to a CT and MRI. So that's about the data that I've seen, but I would love to hear Dr. Praveen's take on what he sees on the field.
So, rightly put, sir. Nothing more to add. So X-rays dominate most of it. But coming from a clinical perspective, not all X-rays need a report. The clinician who is asked for an X-ray knows what to look for. And he asks for a report only when there is some documentation involved. So not all X-rays need a report to say, but CTs and MR, the clinicians are not trained enough to make sense out of it. So every CT and MR performed out there needs a report from a radiologist. So, and coming to CT brains are the most commonly done procedures, followed by paranasal sinuses, temporal bones, things like that, and trauma, which is actually a significant set of cases, is done to rule out fractures. So these are the most common cases that we routinely encounter.
Okay. Right. Maybe another question could be that yeah, I mean, if you see error, this is in some of these model outputs, how do you deal with all the past reports that have been processed by the output by the same model?
So the reports are always done by the radiologist as an input to the radiologist, right? So this is like, we ensure that the next iteration is better. So that's how this is done. So there's no retrospective of it, because this is just an input that goes into the radiologist. We're not like India, legally autonomous reporting is not legal, right? So we cannot have an AI directly send a report. So this falls in some workflow, and there's an input that goes into a radiologist or to the clinician, and they can decide what they want to do. And always the goal is to get better and better in doing this.
Coming to
yeah, sorry,
go
Hannah.
ahead.
But,
Go ahead.
You said this, when we go live, we do a whole bunch of things before it goes live. It's not like, I have a million images, let's go live tomorrow. It's not how it works. Right? So it's because we talked about the slice and dice of the data. It goes through a bunch of stuff. It's evaluated. So we have in-house doctors. Dr. Praveen looks into and evaluates all of it. And there's a whole bunch of doctors whom we try, test, evaluate, get feedback before it goes into a live production. So it's unfortunately, healthcare is not something I dream up something and I can go live tomorrow. It has its gestation period. It needs to go through some trial testing before it can be put into a live production. So we know that by the time it goes in, it is really good, a state of art on where it is right now, and can be used very reliably in production.
I'd like to just give everybody a perspective on the thought process. I'd like to walk you through what a radiologist goes through when reporting a case. This, I think, will add more value and layers to it. So the moment a case is given to me, yes, I look into the history and I go through the stack of images. After that, I might need help. And that is exactly where 5C is a differentiator compared to rest of its competitor. So what 5C does is provides me with something called as a Chronos. It's an active bot from a very trusted source of radiology data information. So suppose, again with an example, I see a hypodense dark lesion in the liver. Now this lesion in this age group might be metastasis, or it could be an abscess, or it could be a carcinoma. So I am seeing that the lesion is lighting up in arterial, it is washing off. So if I just input all of these into my bot, it will give the probable result with a very high accuracy and help me make the most appropriate decision at that point. Now, after having zeroed in on the diagnosis, this LLM, generative AI LLMs, are really a huge game changer. I can actually proclaim to save at least 8 to 10 minutes per case because of these technology incorporated into it. So, and per case, if it is 8 to 10, and look at the number, volumes, and it'll have a huge impact at the to the patient at the end of the day. So generating report also takes a significant duration. To structure a good report, it will take not less than 8 to 10 minutes again. So if these LLMs, at the end of the day, the ball is still in the court of the radiologist to say if it is to approve of it, the final result. But like incorporating AI at every step has significantly enhanced my throughput. So that's how we're trying to bring in a change.
Yes, you've spoken a lot about how AI has augmented. I would like both of you to talk a little bit about regulations that we currently have when an AI product is launched in India, and walk us through the process, and maybe talk about some of the sticky points also, to the extent that you can, in terms of acceptability and readiness in implementing AI within a clinical setup.
No, I'll take the first part, and Dr. Praveen will do the second part. It's always, I like to do the easy questions first. So, so India recently announced CDSCO. That's like the FDA equivalent for India, which where it allows for licensing of both hardware and software products in medical setup. So that's something that that we have gone through. So that's one process that's in place. For a very long time, India didn't have an FDA equivalent, but now we do have CDSCO. That's why even if you see, even a year back, pretty much all of us, including us, every company had to figure out, are we HIPAA compliant? Are we GDPR compliant? How do we do FDA 510K? That's like the theme. But now, at least within the India context, we have CDSCO, which is fairly standardized and competitive to what happens in say FDA 10K, FDA 510K. So it's pretty equivalent and similar in doing it. So in that sense, it's good. Having said this, even general gripe is that the like medical industry is dominated by hardware players and less so by software players, and even very less by AI players. So which means that the regulations that are so easy to relate to for a hardware company, it's really hard for an AI company to understand what that means and then work on it. This all comes as SAMD, software as a medical device, and then go and do it. I wouldn't call this like a battle, but this is something that we need to go through to get it. Be good if we can have a better framework and understanding of doing it. The other thing is there's been a lot more there's been a lot more health data policy mapping. Hasgeek also conducted a session earlier in the year on understanding all of it, but it's all in draft build stage. So legal is not really my forte, so stay away from commenting on it. But there's been things around privacy and how do we go about handling it is something that's being formulated on, and that's something that I urge all of us over here to be very actively involved in, because this is going to make a huge difference to all of us in how it's impacting our healthcare data. So that's something that's important in terms of the policies from a government. So patient privacy protection bill is still in a draft stage, but as software devices, we have SAMD, that CDSCO, where we can register as SAMD. Otherwise, a lot more on, if you really want to get into the field of autonomous reporting, then only autonomous reporting is not still legal in India. It's still far from it, but US FDA does allow for it if you go through a particular state of clinical trials and doing it. And that's one thing for companies can look into. Given our focus, given kind of things that we do, we have built deep expertise in the Indian market, and we believe this is something that can be, we've seen so much variety that it's easy for us to customize for the Western countries. That's something that we are looking into right now. So that's the way we look from legal compliance perspective. Dr. Praveen, if you want to add on the clinical side, that'll be good.
You've covered it all.
Okay, thank you both for the great detail with which and patience with which you've answered all of these questions. There are a lot more questions in chat. There are a lot more questions that we have that
Yeah,
I would
I'll
love.
see if I can handle any of the questions easily. So one of the questions that comes is, aren't X-ray reports a requirement for NABH and ABL? Unfortunately, the problem is ours. Okay, so 1 million X-rays are taken a day. It's impossible for someone, and we don't have enough doctors to doing it. AI is the way to doing it. It's still a very work in progress on how this can be done. We have state-of-art models. For example, we have for degenerative knee conditions, we have models on knee X-rays that are significantly superior to even the FDA approved models. Things that can help radiologists get better, but we still there's still a gap. So experience that we have seen is a lot as you go from South India to the north, more and more X-rays are reported as you go cross the Indias and go up. That's just the data that we see. It's reported less in the south. It's primarily, as Dr. Praveen told, it's also that physicians also look into it and doing it. There's been a lot more challenges. It's a requirement that's coming in. Hard to implement primarily because we have acute shortage of radiologists. So that's one set of question I would take. So,
how is 5C different from Cure.ai? So, right?
I mean, really, I mean, just to tell, we're building AI in radiology is one. I mean, at a very high level, the difference is we do end to end, right? So we call ourselves, we are a full stack AI in radiology. That's where we differentiate ourselves, and it's also blessed to have a huge network of radiologists who help us augment a lot of what we do. So that's and we primarily believe that augmenting using AI for radiologists is the way to go, and that's our primary differentiation in what we do. More competitors always good for patients, so I would urge many more of you to start building AI in radiology. So that's something I would do. There's been some questions around pneumothorax. Okay, so pneumothorax is something that Dr. Praveen also talked about. It's when air gets trapped in the lung. It's a very critical finding. It needs to be acted upon immediately. So it's good. I didn't know that Kaggle is running a competition, but it's something that we also have an internal model. It's something that's critical, needs to be flagged immediately for every life-threatening problem that's out there. I really believe that AI is the first level of intervention screening before it gets to a radiologist, because prioritization is super important. There is a question for how many diagnostic prescriptions per 1,000 per 100 persons. It's probably a great question for Anand.
Yeah,
Just so you all know, Anand is also a doctor. He's been unusually silent though, just asking us questions.
Yeah, that's the job. So I don't think I have like a ballpark figure for this, but it's definitely an interesting thing to look at. What is the density? Yeah. Cool. So Hannah, any last comments?
No, I think just wrapping up, but one of the things that, I want to put out there is since you have mentioned that you are the largest provider with end-to-end solution, and also the number of just the sheer volume of images that you're seeing from a patient cohort perspective, this is a request that we would put out is you are building these tools, you're building these templates and standards. Would a 5C be interested in extending this training to technicians, bar radiologists, for wider community adoption? That's something that, I would encourage. I don't think that's something that you need to answer on this, platform right now, but it's something to really have in mind, because when you are the largest provider and you have that capability that you are building, if it can benefit a lot more technicians just by going through your process and knowing, okay, these are the minimum number of points that we need to ensure quality of data, and that in turn makes reporting much better. So that's something that I would leave as a thought. Apart from that, I think it was a great session. Thank you both
really
for
nice.
Just on this, so we actually do this right now. We just started doing it. We're trying to do 3 to 5 sessions every week, where we get a small set of people, either physicians, specialists like neurosurgeons, or radiographers, technicians, and then do very specific focus training on how they can get better, right? So this is something that we've already started doing. Extremely great idea. So we'll anyone's interested, please reach out to us. We'd really love to collaborate and do. This is like something that we believe that the standard has to get better for collectively, for all of our well-being to get better, right? So that's something that we truly believe in.
Cool. Thank you very much for your answers and participation, and see you guys next session. Yeah, bye.
Thanks, Anand. Thanks,
So
Hannah.
much.
Thanks,
Thank
Anisha.
you.
Thanks, Hasgeek, a lot for doing this session.
Thank you so much.
Thank you. Thank you so much.
Good night.
Okay.